know. So welcome to today's TeX Hour, which is accessibility of command line interfaces. And we're very pleased to have Alice Merrick in as our special guest, and she's the author, along with two of her colleagues at Google, of a paper on accessibility of command line interfaces. And it's, roughly speaking, the starting point for a conversation. Let me just say a word about how I discovered this paper, which is that I've thought for at least a couple of months that getting the right people into contact with each other is actually quite important. It's also harder than it sounds. And from what I've picked up from the blind math list and the visually impaired programmers list, I discovered that both of them at the same time are expressing a lot of interest in machine learning. The coders list were, what accessible tools are there for doing machine learning stuff, and command lines, is this command line accessible, and that sort of thing. And on the blind math list, it was, well, I'm going into machine learning and I'll have to learn some statistics. And there's a great gem on the blind math list whose name is Jonathan Godfrey, who's a professor of statistics at Auckland University, New Zealand. And he knows a tremendous amount about accessibility for visually impaired, and that's because he's blind. And he prepares all his materials using the R markdown system. And that's great for him because he can use that, because it's all marked down and command line, and it produces both PDF outputs for the people that demand it and web outputs, which are accessible to him. And he's been a great contributor to the blind math list. And I've also been involved a little bit in the Elm programming, and they're quite web programming. They're quite interesting because they have a real model. When you write a web page using Elm, you have an actual real model that's separate from what you see. And so you can put new controls and so forth on it. And I see that as opening possibilities. So I did a search for accessibility and command line interfaces, and I found the paper that Alice and others had written. So I thought, okay, we'll talk about that this week. And Alice has been game of sport, we say in England, and decided to come along. And so that's the background to it. I think at this point I should pass over to Alice and ask her to introduce what she wants. I think she can ask us to provide information or ask us questions if she wants to. I should also mention that Nelson Beebe, who knows a lot about the early history of Unix, which is where the powerful command line interface came from. Unix was the first system to have a powerful command line interface. So there's a real opportunity to learn about the history of that from somebody who was alive and in computing at the time it started coming out. So I hope that's enough to let Alice get going.
Sure. Yeah, I didn't come prepared with, any slides or anything. I did not know that this group existed, so this is it's all very new to me. I guess if I were to just come up with some things off the top of my head, I would like to know maybe about problems that each of you have experienced in using command lines, and also maybe when these has that changed over time? Because originally we might have always, everything was command line, and I'm curious as command lines became more mature, and people got more clever, with putting in things like ASCII and things like that to make things visually formatted, if things have become maybe less accessible over time.
The difficulty we have in that is that we're not a very good sample audience for accessibility. Yeah. And in particular, what is it? I think it's called the survivor paradox, that we're the people that have succeeded. Certainly with TeX is rather unusual because you write your document in Markdown and you don't see what it looks like until you've typeset it. And in the old days, it took a minute or two before it was typeset. On the other hand, you knew exactly what you were saying. So it's the old books that were sort of written using typewriters. That's the sort of origin, if you like, of the command line interface. And I believe the first command line interfaces actually interacted through a teletype terminal, which is a roll of paper that you type your inputs and outputs on. And I believe that some of the early teletype terminal programs, when you inputted a password, you inputted the password, pressed return, and the teletype then printed asterisks over the password to obliterate it. So the whole, that's not exactly answering your question. I'll stop because I'm digging a hole.
Just briefly just briefly on how it's changed, I think one of the most important command line inventions is the recall buffer.
Yeah.
So, and I'm not familiar.
So normally when I'm doing something like typesetting a TeX document or something, I usually, write some text and then process it just to make sure I don't have any typos or whatever. Write some more text, process it again. So I'm repeating the same command or a variant of it very, very often. And I don't have to retype the whole command each time. I can just recall it from the keyboard, edit it if necessary, and run it again. So it's, type it in. I try to avoid typing anything in more than once, right? So if I'm writing a program, then if something is needed more than once, it becomes a subroutine. If I'm writing a web page, if the text is repeated, I use an include file or something. And on the command line, you type the command once, and then if you need it again, you recall it, maybe edit it a bit. And I think for me, it's much more efficient than some sort of GUI.
Yeah. So I've spent a long time in scientific and mathematical computing environments, and I co-manage a facility with about 20,000 users. And consequently, I have to deal with lots of different things and lots of different files. And GUIs are totally crippling when it comes to such a task because they're predicated on the notion of clicking buttons to do something on a single file. Whereas the thing I do many, many times in the course of a day is do the same thing on a set of files. And this becomes totally trivial with the shell loop, where you can loop over a pattern that matches a number of different files and do something with them. And people who only know the graphical user interface are really crippled. They simply cannot do things that I do routinely in seconds. And so my feeling is that it's perfectly fine to have a graphical user interface that is wrapped around a command line interface, but offering a GUI by itself is completely unacceptable because it's not programmable. It's not automatable. It's predicated on being able to see the screen and knowing where to click to do things. And a visually impaired person has no hope of dealing with that. So I spend, although I do certainly work in the windowing system, I use cut and paste hundreds and hundreds of times a day. I'm really essentially almost always in a command line version of something, whether it's a text editor like Emacs or it's one of the Unix shells in a terminal window. And except for web browsers where I have half a dozen different ASCII browsers, but I don't use them very often. If I want to do a search for a topic, then I tend to use a GUI browser, and that does what I need to do. But almost everything else where I'm creating the input is not done in that environment because it's just too limiting. And it's not reproducible, it's not repeatable, and it's not automatable. And those are all key things about computers, that computers are good at doing the same thing over and over again. I mean, look at the robots on assembly lines the world over. I heard this morning on a BBC report that somebody has just bought a robot that can make 200 pizzas an hour, and another robot that can deliver them to the customers. So
yeah, that's something we've also found in cloud. Like we have a command line interface, and there's also browser-based tools, ways of accessing things, and they put lots of resources behind things that are the GUI thing, and we find that actually this command line gets a lot of usage. APIs get lots and lots of usage because that's how people can do things programmatically. If they need to spin up instances of a VM or something, they need to do that programmatically, or a lot of it at once. That's not something that you're going to sit and click 100 times in a browser to do. But yeah, it just shows like the important, like command lines are not going away. Yeah,
I certainly hope not. If they do, I will go away.
yeah, they are incredibly valuable. So even whether you're cited or not.
Philip's comment about I can't remember exactly what it was. It was
recall buffer.
Repo buffer.
Recall
No,
buffer.
Recall buffer, yes.
Yeah.
So I've cobbled up an example which I've put in the chat, which I'll read out for you. It's history pipe. Pipe is a vertical bar. It's a character that we call pipe. History pipe grep PDF pipe tail -5. That gave me the last 5 commands that I've issued that contain PDF in them somewhere. And if you look at them, you see that the last one was the one I just issued because it meets the criteria. And then I evinced something from Mountain Warehouse, and then I did an ls-l which PDF LaTeX and a less $which PDF LaTeX. I can tell you a bit more about those later. And I also did a which PDF LaTeX. The first thing is history gives lists out all the commands that it's kept a record of. So this is the reproducibility that Nelson was talking about. Every time you issue a command, it goes into the history.
Mm-hmm.
So that is an embryonic log file. And then the pipe command says, don't show me what you've produced. Use it as the input for the next command. So that's why it's called pipelining. And grep searches the input line by line for whatever the argument is, which is the 3 characters PDF together. And then tail gives you the last 10 characters of last 10 lines of the file, unless you give a parameter saying you want something other than the last 10, and I say I want the last 5. So that one command can tell me the last 5 times I did something at the command line that relates to the PDF file. And one of the things Nelson and I were talking about this is that the piping of the output of one command into the input of another command is a capability of the shell. It's not a capability of the commands. So you don't have to make the command do anything special in order to use it in that way. And grep is generalized regular expression parser, which basically is, here's a tool for looking for things in text files. And it will do 80 or 90% of the looking that you want to do. It filters out the things that you're interested in and throws away the rest. So typically with grep, you've got a file with 10,000 lines and it only shows you 3 of them. Or it may be that you're looking for the absence of errors. So you search all the lines and you say, show me all the lines that contain an error, and you're hoping to get no output. So Philip has used the recall buffer, which is the same thing on VMS, and he's done something similar for what he's done. So the point I think you might be interested in there, Alice, is that the command line interface got to be a powerful tool because people were using it a lot, and because the people that were using it are actually the people who had written the whole system. Okay, so if you ask him to, Nelson will tell you a little bit about that.
Yeah.
Or wait to be asked, Nelson.
Okay.
Or you could move on to another question and ask for some more information.
What is is Nelson, was he part of building the system?
No, but I was an early user, and I just wanted to make a comment about pipelines, and that is that the programs that lie between the vertical bars that are the pipe symbol, they can be written in arbitrary programming languages. And for those of us who are old enough, if we went back to the 50s, 60s, and 70s, programming languages did not interoperate. They wrote file formats that were illegible to any other programming language, and you couldn't cobble them together usefully. And the beautiful model that the Unix developers at Bell Labs decided was, look, why don't we keep most of program input and output plain text? Because then it can be printed if we need to. We don't need to understand any complex binary format embedded in the stream. And we can process it in different languages, picking whichever language is most convenient for the job. The author of the pipeline, Doug McElroy, is at Dartmouth in New Hampshire, and a frequent contributor to a mailing list that I've been on for a number of years called TUHS, the Unix Heritage Society. And if you search for TUHS archives, you can find the online archives. They're public, and Doug has dropped in over the last year some historical commentary on how the pipeline idea was introduced and how quickly it took over Bell Labs, because it made so many things so much easier. It's a remarkably simple thing that a single character from your keyboard could join two programs together. If you ever worked on an IBM mainframe, you wrote job control language, which was very idiomatic and usually took multiple lines, and you had to tell it things like the name of the device you were using and how much disk space to allocate and so on. It was hideous. But a pipe symbol makes it trivial to make one program feed into another program. And it also encouraged the notion that instead of building complicated software, let's build a whole set of small tools that can be joined in curious ways to accomplish what we're trying to achieve. So as an example of what I do with pipelines, I have a very large bibliography archive of about 1.7 million entries. And it's created by pulling web pages from many different publishers and converting them to BibTeX form and putting them into a database. And that processing step is encapsulated in a shell script that has somewhere of the order of 30 or more pipeline stages, each of which do a small task. And the beauty of that is that if there's an error in one of them, it's very easy to identify where the error is, because you can put in another command in the pipeline to track what's in the pipeline and look at it. And as a result, most of those programs tend to be relatively small. Whereas the approach in the Microsoft world is you build these enormous applications that have built in all kinds of bells and whistles and spell checking and other things that mean that while they work just fine in that GUI, you can't apply them to any other document that isn't in a format acceptable to that program. Whereas in Unix, the spell command, which actually was originally implemented as a pipeline, and there's a very nice description of that by Brian Carnahan now at Princeton, but for many years at Bell Labs, of how that came about. So the spell program can be used for a great many things, and on almost any document you can think of that has text in it.
think a good illustration of this is the years ago in the communications of the ACM, there was an article about the contest between Knuth and perhaps the person you mentioned.
Yeah, it was John Bentley, not Brian. John Bentley and Don Knuth.
Yeah. Knuth wrote a really nice program, but it was nothing compared to the 6 or 8 lines that solved it for the other guy.
I'd like to draw something out of what Nelson has just told us, which is that the Unix command line interface is an example of a system that is being created by an empowered community of users. And I chose those last 4 words deliberately because that is one of the things I believe that lies at the heart of accessibility, and to a certain extent also usability, that the community of users are empowered rather than isolated. And Kernighan and Ritchie wrote their own operating system, and they called it Unix, and they made it to suit themselves, just as people who cook to please themselves. And as Nelson said, there was an intellectual ferment at that time. I think it was the 60s. A fantastic book called The Psychology of Computer Programming by Gerald Weinberg. Absolutely wonderful book. Have you seen it, Alice?
I have not. I have not even heard of that one. That does sound something that's up my alley.
It does sound. It's cognitive. It's one of his examples is where there was a flaw in a complicated system, and they found that somebody who was aggrieved at the work that they were doing had didn't trust somebody else's software, so they wrote their own, and it misbehaved because it made assumptions that were not true. So sort of that was an example where somebody's poor feelings caused poor cooperation. A lot of faults are psychological. A lot of difficulties in programming are psychological. But an empowered community of users is what the command line interface provides.
Yeah.
Do you want to say something on that?
I was gonna say, like, if you follow Program L, and actually I'm not familiar with the blind math group, but I do follow Program L, and you definitely see a lot of that in the community of, you know, people working together to, you know, solve problems that they all share. And I'm curious, like, in tech, like, with this group that you have here, is that something that you are working on building, not just in terms of groups of people who maybe use a screen reader or people who are blind or visually impaired, but kind of like bridging between people who are sighted and non-sighted to like work together on things that will be like empowering for everyone? Is that kind of the goal here, or do you have thoughts on that?
Okay, well, this is a group of people that have come to the Zoom meetings I've been organizing. Actually, these Zoom meetings started as a consequence of 2 events. The one, of course, is the pandemic, and the other is that the UK Tech Users Group was becoming moribund, and the powerful forces on the committee wanted to dissolve the group. And being a long-standing member of the group and not wishing to lose it, I was opposed to this. And but I found that the interest was elsewhere than where I thought it was. And in fact, last year, we had almost a year ago, we had a very well-attended meeting on accessibility. There were about 20 people came, and I couldn't do anything with it because I didn't have the resources, if you like, to follow it up. So that's this particular group. My view about TeX itself is that TeX is a very good typesetting system, but the LaTeX system that is built upon it is past its golden age and is in a number of ways an obstacle to accessibility.
And when you say LaTeX system, you mean like the turning things into PDFs?
No, because LaTeX is a sort of front end.
Okay.
So LaTeX is in part a text transformation language. In part, it's a language for transforming text from one form to another, as Nelson was talking about, except it doesn't transform text to text. It transforms text to a non-existent internal format. It sort of becomes a stream of commands that you can't capture and you can't do much with. And the Jonathan Godfrey doesn't try and create PDF that is accessible. He tries to create output that's accessible. And if I can, I'll actually quote from your recommendations. The fourth recommendation is provide a way to translate tables in CLI output into another accessible format. Now, LaTeX is geared to producing PDF output, and there's a project taking place now to change the foundations of LaTeX so it becomes easier to produce what's called tagged PDF, which a screen reader can more properly read. But that won't help anybody for several years. And in any case, it will help only people who want to read PDF documents. A lot of people want to read HTML documents or EPUB documents. You know, in your recommendation 4, translate tables into another accessible format. They're not asking for a more accessible CLI output. You're saying produce an output that's not a CLI output, but which is more accessible, probably HTML. So for your recommendation 1, ensure that an HTML version of all documentation is available. Well, actually, the LaTeX documentation, by and large, is not available as HTML.
And are you suggesting that you would like it there to be a version of it that's HTML?
I'd like much more of it to be available if people had used LaTeX, and that particularly applies to LaTeX notation mathematics, which is used on websites in MathJax. MathJax is the greatest contribution the tech community has made to accessibility, and it comes from outside the mainstream tech community. MathJax makes mathematics accessible on web pages. So yeah, over to you.
I was going to say, are you curious about our reason for suggesting this? Because I could talk about that.
Suggesting what? Oh yeah.
Well, yeah, for the first recommendation or the fourth recommendation, I can.
I think you should, if only for the video, people watching the video.
Okay. Yeah.
Tell us why recommendation 1, that there should be HTML version of all documentation available.
Yeah, and the reason for that is in a CLI, typically the documentation will be available in what they call a man page, and that if you look at a man page, it's visually structured. So you might have things that are spaced out by like paragraphs to show like different flags, or you might have some things in all caps, or some things that are bold or underlined to kind of make them easy to, visually go through and find what you're looking for. But there's no underlying structure to that. So you can't, typically when a screen reader, for example, but this could be true for, any kind of alternative input device that's like keyboard based, is going through a web page, you're navigating by landmarks. So one of the most common ways of doing this is by HTML heading, so H1 or H2, and it makes it easier to get through a document instead of having to go line by line, which is what a man page essentially forces you to do. And so having an HTML version of that uses the HTML structure, although you know, if there's underlying structure, that's the important part, but the HTML gives the screen reader the underlying structure so that somebody can more easily navigate the documentation.
I note that man pages actually do have structure in the input stream, but the structure is lost in the output. And it's the same issue with TeX and LaTeX, that you may well have marked a chapter or a section in your input stream, but by the time it reaches a screen reader or a PDF viewer, the notion that the text of that heading was a chapter title is gone.
Mm-hmm.
I'm no expert on Unix, but hasn't the man page been superseded by info or some such system?
No, they really serve different purposes. The man page is intended to be a relatively compact description of the command, and the info file, which is written in a pure ASCII text intentionally. It can produce typeset books, but it can also be read on the screen in a text editor. That's intended to have much more detail. So the man page of a command might be 1 or 2 or maybe even 5 pages long, but you might have a 50-page manual for it in the info system.
I think I remember once a command man whatever saying the man page is obsolete, please see the info or something like that.
Yeah, and that's wrong-headed. People who have said that have not understood the point of man pages. Yeah, it's a difficult problem. The beauty of the info system is it's very easy to learn. There's about 10 characters that do anything at all in an info viewer, and you can go forwards and you can also go backwards to where you've been. A huge flaw in most web browsers is that when you follow a link to some other place, you cannot get back to where you were, at least not easily. Sometimes you can find a history list and sort of work your way back, but it's a 1-character command in the info system. Another very nice thing for, say, a programmer who's consulting documentation in man page format is I can have in one window, say the info documentation of what I'm trying to implement in software. I can type Q to quit out of the documentation system, keep typing, and then I forget, was it a 3-argument command or a 4-argument? So I type Control-XI and I'm back in info exactly where I was before. And since, Philip, you're very familiar with the VMS help system, it may have improved since the early days, but back in the 80s and 90s when we used it, I found it very frustrating that it could not let you go back. It would always put you back at the top of the help tree, and you'd have to work your way down. Perhaps that's been fixed.
If you enter a question mark, it goes 1 level higher up.
Okay, so that they have addressed that problem then. But
yeah, the input file is actually just a text file with minimal markup, and it's sort of compiled for use as the online help. But the structure itself is pretty simple, and there's a common web script which displays the output of help as HTML. You know, so it's something which is very easy to understand and convert to another format.
Yeah. Many years ago, I wrote a tool called Man to HTML, which converts man pages into HTML markup, and I've used that for probably 3 decades now, because it does preserve structure and makes it easy to see the manual page in a form that a web browser can deal with.
Okay, I'm going to act as chair for a moment.
Yeah.
First thing is we normally stop at 7:30, but if Alice is willing to stay longer, I'm very willing to let the meeting continue as long as she likes. So that's up to you, Alice.
I would like that, but I do have another meeting like right at that cutoff, so I will have to run off in 5 minutes.
Okay, so in that case, what we better do is come to our important conclusions. The most important vote here is from Alice. Would you like to meet again? To
Yeah,
discuss
sure.
some of-
Yeah.
Okay, so you're up for another meeting. And are there any things you particularly like to talk about?
I mean, I would be curious, like how you, how tech might use these guidelines, or if you have plans on using these guidelines, if you have things that you think, aren't addressed by the guidelines. I'd love to hear about that.
Okay, so you're interested in the applicability of these guidelines to our community.
Yeah.
And is there anything we can give you in return?
Oh, I'd have to think about that.
Would you like to have expert opinions, or at least from the Unix point of view, expert opinions?
Sure.
On, yeah. So expert opinions, for example, on translating producing HTML outputs for the documentation that's available. So the man to HTML command, if that could be incorporated into the, okay, so here, I'm going to put words into your mouth, which you can say,
Okay.
oh yes, I like that.
Okay.
Which is, the shell controls a great deal of things.
Mm-hmm.
So the command line interface can actually vary from shell to shell, even though the underlying behavior is different. So there's the C shell and the Z shell and the bash shell and probably a few others. And if we had a shell that was accessible, in other words, it did its best to provide accessibility for the output. So the history, for example, is a shell function. The shell controls what the history is. The commands don't control the history. So, so I'm going to put this into the chat. Application of guidelines to tech community to tech / by tech community. I think that's your first request, isn't it?
Yeah.
Please study these guidelines and tell them how they apply to you. And then the reverse gift of sorts is, what would an accessible shell look like? So an accessible shell is a shell that has exactly the same commands, so to speak, as the current shell, but is geared for visually impaired users, for example. E.g., making use of command history and autocomplete, which we haven't talked about. Autocomplete allows you to tab complete.
Yeah, I would be curious to, that wasn't something that we studied in particular, but that would be an interesting accessibility topic.
Yeah, so you could type the first 2 letters of the command and hit tab, and it'll give you the whole command if it can.
Mm-hmm.
And how about, roughly speaking, the same time next month?
Yeah, I think that this time works for me.
Shall we give you 30 seconds to leave early so that you can be ready for your next meeting?
Yeah, that'd be great.
We all give.
It was a pleasure meeting all of you.
It's been great having you.
It was a pleasure to meet all of you. Yeah. All right, I'll see you in a month.
Take care.
Bye.